Okay, now it's official. Okay, awesome. Welcome to live stream number 2. Definitely stoked. Last week was super fun, so this week will hopefully be even more exciting. Kind of got a different set of topics today. We're going to talk about we're going to briefly revisit the Word Mac malware because there's some kind of interesting developments in that. We're then going to look at some new Mac malware that Malwarebytes discovered yesterday, kind of pull it apart, analyze it, and figure out what it's trying to do. We're then going to look at a vulnerability that I discovered in Mojave. It's now patched, but it impacted Mojave and allowed you to bypass a bunch of their privacy features. So we're going to discuss how I found the vulnerability, how the vulnerability works, and then we're going to write a proof of concept to show how to exploit the vulnerability. And then we're going to end, if we have time, I want to show how we can create a keylogger detector for macOS that can detect a wide variety of the most common Mac keyloggers. We're talking about malware, exploits, also good to talk about some defensive tools and capabilities. So as always, I want to thank all my supporters on Patreon. I also want to thank the friends of Objective-C. First and foremost, Digita Security, wearing their lovely t-shirts. Sophos, also a big supporter, so mahalo to them. Similarly, Malwarebytes, SmugMug, Guardian, Mobile Firewall, and the Secure Mac. So mahalo to those companies. They are very supportive of everything I do. And if you are listening and you want to join this company, this company of companies, there's some more information on the website. So I'll just paste that link here. So if you work for an awesome company that wants to support my research, the free open source Mac security tools I write, maybe show them this link. Okay, so let's begin by talking briefly about the malicious Word document that we analyzed last week. And what we did last week, we showed how to pull it apart, how to extract the macros, how to analyze the macros. And then what we did is we connected to the command and control server and downloaded the second stage payload, which turned out to be MPyre, which is an open source. It was actually Meterpreter, which is an open source Metasploit module that allows you to completely perform any action you want on an infected computer. So one interesting thing that I did not mention is if we look at the macros, there's some kind of interesting logic that's going on. Specifically, if we look at the path they're building to the plist, that's kind of interesting. It's like dot dot slash, interesting. Also, if we look at this bundle ID or this label, com.xpnsec.sandbox, that's kind of interesting as well. And so we looked at this a little closer and I thought about this and it really rang a bell. And what I wanted to do was talk about how it relates to something that earlier we blogged about on Objective-C. So in August of this month, there was a guest post on Objective-C by Adam Chester. And he wrote about a sandbox escape he discovered that would allow for example, a macro in a Word document to escape the sandbox, the Mac Microsoft Office sandbox. So current versions of Microsoft Office are sandbox, meaning if there is a malicious macro in them, even if the user clicks allow and lets the macro execute, in theory, there really shouldn't be any damage done. You shouldn't be able to persistently install a launch agent because of this sandbox, which should block that. What Adam found, though, was a really neat bypass, which basically allowed him to escape from the Office Word's sandbox and do things like persist. And this was due to a faulty regex. We're not going to go into that, but it's kind of described really well in this blog. I'll post this link really quickly in the chat room is here. So again, kudos to Adam for this lovely bug, and also thanks again for him posting it as a guest blog on Objective-C. Plug for Objective-C's blog. If you have some Mac security research that's kind of interesting and you want to post on the blog, I would be super stoked. A lot of people read the blog. Obviously, we'll link it back to your personal page, your Twitter account, whatever. But anyways, in his blog, he basically showed how you could do something like escape the word sandbox using macros and do something like persist. And if we start looking at some of his code that again was posted on our blog, we start seeing some similarities. So we see calm, xp, xnp sec, we see Python. Interesting, interesting. If we look here, we see, again, this path. Very interesting. So if we go back to the attacker's malicious Word document, we can see they use this exact same code. So basically what the attackers likely did was read this blog, which is flattering, means someone's actually reading these blogs, and then they created a malicious Word document. Obviously, they swapped out the payload to put in their own malicious logic. And as we saw, this was a downloader, specifically here, that would connect out to their command and control server to download the second stage implant, which was Metasploit's interpreter. But other than that, they used Adam's code as is. So it's kind of interesting to see that attackers are paying attention to what security researchers are publishing. And in scenarios like this case, they're actually weaponizing sometimes these proof of concepts and then trying to target Mac users. So I thought that was interesting. And again, kind of was at least neat to think that everyone is reading this blog. I'm also not sure if Microsoft Office has patched this bug. I didn't get a clear answer on that. Hopefully, though, Microsoft releases a bug fix for this because, again, this is a flaw in their sandbox implementation. They basically have an exception that tries to allow Word to write files to the temporary directory, but their regex they use, which specifies to the sandbox which files are allowed, is faulty, basically allowing a macro to create a custom path. I think if it has a tilde in it, it basically matches the regex, but can be anywhere on the file system. All right, so that's detailed a little more in the blog. Again, I wrote up the details of what we talked about in the last stream. So again, here's the link for this. And the previous blog that Adam wrote details more the sandbox escape that the attackers used. So now let's talk about some new malware that was very recently discovered by Malwarebytes that they have named LamePyre. And they provided a hash for it. Where's that write-up? So what I did was I hopped on VirusTotal and downloaded it. They were kind enough to upload that. Let me just see if we can find their other blog posts where they detail this a little more. So they talk about the Word document that we discussed. And they talk about this LamePyre, which we'll discuss in a second. So here's the malicious binary application that we are going to look at today. Again, this is a new piece of Mac malware that was discovered by Malwarebytes. What we're going to do is we're going to take this sample and I'm going to illustrate kind of what I do when someone reports a new piece of Mac malware, kind of walk you through the steps I take to briefly analyze it, pull out its logic, and basically see what it does. So if we go to VirusTotal, I don't know if I'm logged in. Search. But we should at least be able to see this file. We can see at this point, no engines have detected this file. Again, I always do like to caveat that engines on VirusTotal are sometimes different than the engines that are running on end user systems. So obviously Malwarebytes is now detecting this. Perhaps the signatures on VirusTotal are a few days behind, or their engine is somehow different. But it's still interesting to show that at the time of discovery, it's likely that none of the antivirus products detected this new piece of malware. And I've said this many times, but especially for macOS, this is really not that surprising because the majority of antivirus products for macOS are doing basic signature detection. They're not really doing a lot of advanced heuristics, which means if someone writes a new piece of Mac malware, more than likely it's not going to be detected by any of these more traditional products. It's not to knock them too bad. I mean, it's still good to perhaps have a antivirus software running on your Mac. I personally don't run one, but for the average user, it's hopefully will detect them against a lot of the known threats. Okay, so I went ahead and downloaded this app, Discord app.zip. We're going to hop into a VM because it's always good to do malware analysis in a VM. And what we're going to do is we're going to start pulling apart this application. So somewhere over here, I have the file. Okay, so let's copy this. So the first thing we kind of notice is it has the Automator icon. And actually, Malwarebytes noted this in their report and said that, this is actually a Automator script that has been compiled into an application. I don't really know much about Automator scripts, but basically they allow you to automate tasks on macOS. I'm not sure why the malware author decided to create an application that was based on an Automator script, but that's what they did. So the first thing we can do is we kind of look at the package contents of this. We can see that standard info.plist. There's this thing called document.wflow. We'll take a look at that in a minute. That's not something that you normally see in an application. macOS is the main executable. I'm guessing if you create a Automator script and then convert it or compile it or package it as an application, what macOS does is basically has a standard application stub that then might in turn execute something like the document workflow. But let's first take a look at the info.plist. Again, this is probably automatically generated when you compile your Automator script. So I usually look for the main executable. Oh, so great question. I noticed you uploaded the malware as a zip. Does VT scan the binary inside the zip? And the answer for that is yes. So since it's an application is actually a directory. It's really just a folder. So you have to zip apps to upload to VirusTotal. So what VirusTotal will do then, and actually if we go back to VirusTotal, we should see I should have logged in. But we can see, for example, they have detected that, yes, this does include a Mach-O and also a Mac application. So VirusTotal is actually pretty good. What they'll generally do is they'll take the zip file, decompress it, and then scan all the components. And if they detect a Mac app, they actually have other logic that they apply. Basically, they have Mac app specific scanning logic. So for example, they'll extract the signature of it. They'll pull out other metadata, and they'll probably, and they actually even run it in a sandbox. So here we can see there's some details about it. The files it creates, doing some Python stuff. We see some IP addresses. So again, great question. If you guys have any other questions, feel free to jump in at any time, and I will try to answer them. So if we hop back to the VM, okay, we have this info.plist file. We can see the bundle name, discord.app. I guess this is, the attacker is trying to get users to run the application. And so what I'm going to now do before I run the application, I'm just going to download some of my tools, if I can spell. And what we'll do is while we're analyzing this malware, because eventually we're going to run this, we're going to see how some of the tools I've created can help us analyze or detect the malicious behaviors of this. So let's download first KnockKnock. And let's see, what else should we install? Maybe BlockWalk. Download this. And then I think I want, what's your sign? Here we go. Man, all these pop-ups. Who wrote this site? So, oh, thanks, Mikey. It's awesome that you guys know more about some of the stuff than I do. I mean, I really mean that, and I really appreciate that. So, Mikey Mike is Python guru, knows a lot about macOS stuff. So follow him on Twitter. And also, he just mentioned that Our assumption that the stub app in the malware, the executable, likely just runs a script is correct. So thanks, Mikey. Another question is, why do you think the ML engines like Cylance don't detect this malware? That's a good question as well. I don't have a good answer for that, but my guess would be that a lot of them just aren't as powerful on the Mac side of the house. And there's a few reasons for that. And we can talk about this for a long time. I'll try to keep it short. But basically, a lot of the ML type stuff works well on Windows, largely because there's more Windows malware that they can train their algorithms and their detection heuristics on better. On Mac, there's so few samples, it's really hard to detect. Also, I'm not sure how powerful the ML engines on, or the heuristic-based engines that are on VirusTotal. For example, Cylance, I know CrowdStrike has one. So again, likely if this malware was ran on a machine, an end user machine that had CrowdStrike installed, they might detect it if it starts doing some malicious activity, like persisting a launch agent. That's something that's very common that malware does. So I would hope or imagine that these more heuristic-based endpoint protection software products would detect that. But again, I don't know if the ones on VirusTotal just aren't, the optimized ones or the ones that are the same that are running. Again, as someone just mentioned, it's also possible that the VirusTotal versions of the engines aren't, don't have the macOS capabilities or heuristics. So basically, when I see something on VirusTotal, if it's not flagged by anybody, it's probably just new. If it's flagged by a few people, it's probably malware and likely flagged by lots of other systems in the wild. But again, I don't have 100% insight into that. Okay, so let's install some of these tools I just downloaded, again, on the VM. So let's start with what's your sign. Yes, we trust it. Okay, restart Finder because Apple makes it difficult to install Finder extensions. And then let's also install BlockWalk, because if the malware is going to persist, hopefully BlockWalk will detect that. So let's authenticate, run this quickly. Okay, and then let me grab KnockKnock really quick. Awesome. Okay. So, okay, nothing too interesting stands out to me in the info.plist. Again, this is probably automatically generated when you compile something, an Automator script. Seen that. So now let's go and look at that document.wflow file. Let's first run the file command to see what type of file it is. Okay, it's an XML document, very long lines. So if we look at the contents, we can see that it looks like perhaps an Automator script. This looks interesting. Ta-da. Okay, cool. So here we have this action bundle path, and this points to run shell script. So again, I'm assuming this is how Automator scripts work. Basically, you compile them. Apple has this key they add, and they point it to the standard script executor to run whatever you specify. This is kind of interesting. Does anyone speak Russian? Not sure what that means, but it looks like it's a foreign language. This could provide some attribution. Obviously, this could be fake, but again, the legit Discord application probably doesn't have foreign language characters in this. What? So Mike, our malware expert, has told us that this translates to load shell script, run shell script. Awesome. Thanks, Mike. You should come to all our live streams. Okay, so we then see this command string and this payload data, and immediately there's this large chunk of data. Again, if we look at the end, we see the padding equal or single equal is often an indication of base 64 encoded data. So again, this is likely what the malware executes when it gets run. So we can grab this and we can actually decode this. We can probably do this quickly in Python. So if we import base64 and let's say payload equals blah, and then if we say base64.b64 decode payload, awesome, this decodes. So let's grab that and copy that into a document so that we can see that more better. Come on, Spotlight. Text edit. So again, we base64 decoded the initial payload, and we can see this is some Python code. It's all kind of, not pretty, let's say. But we can see some things like expand user and add a hidden file called .system. We see something else called base64 payload underscore base64, which looks like more base64 encoded data. And then something called screencast base64, which again looks like more base64 encoded data. So it looks like our base64 encoded payload had another payload that once we decoded had more embedded base64 encoded data. So what we can do is we can hopefully decode this as well. So we can look at these other parameters. Again, this is the payload that will get executed. We can see there's a bunch of config data here. So it looks like this is probably a script or something that the attacker could customize perhaps for various installs. And a lot of times we see attackers doing that because this will make each instance of the malware kind of look different. For example, have a different name, might be persisted in a different location. So if AV engines are perhaps looking for things specific name, we can do that. CyberChef to beautify the code. I don't, but I should. I wonder, can I do that online? Yeah, maybe let's see if we can find something online to beautify this with. CyberChef. Ooh, look at this. I don't know if I can decode this online, but, oh, it also has decoders. Awesome. Data format. Okay, so input. Bake? I have no idea what I'm doing. If there is a beautify script here, paste the code in the input and search for generic code beautifier. All right. Awesome. Oh, come on. I'm clicking on it. Beautify. Huh. Does that not? Okay, there we go. Click and drag. Okay, cool. Awesome. So we got it. The recipe section. Looks like it didn't help too much. Oh, we can try this again. Auto bake. Let's try this one more time. Okay. Let me try Python formatter online. And we'll just see if this beautify format. Okay, this one's a little better. We can see it's basically, if we peruse this, we can see it is doing stuff like building paths, executing this. We can see subprocess p open, execute, and we can see something here called launch agent create, and it looks like it has an embedded plist or property list. So we can see that what it looks like it's doing is it's writing out the decoded screencast base64, and the base64 payload as well. Question, what kind of keyboard is that? It is a Logitech keyboard. The only reason I use this is because it has the ability to pair with multiple Bluetooth devices at once. So I can just press a button and it'll pair with my work MacBook and my personal MacBook, which is kind of cool because the Apple keyboard, or at least the old version I had to manually unpair it. I'm gonna turn on the fan because it's getting a little toasty in here. Come on. Awesome. Okay. Struggles of living in Hawaii. It's hot in December. Okay, so looks like this payload is going to, oh, it's a little high. Looks like the payload itself is going to write out a launch agent property list, which we can see embedded here, and then decode some base64 encoded data as well. So if we hop back to our VM, let's decode this. We could do this in CyberChef, or we could just do this in Python again. Since we already have the Python here, let's just do this. So let's just call this A equals that. And if we do base64 dot B64 decode, I always forget what the syntax is. A, cool. We can see more Python with more base64 encoded data. Oh my God. Well, let's take this and let's decode that. Oh, this, come on, trackpad. Okay. B equals, oh yes, I will share the hash in 1 second. Okay, so let's try to decode this. And this might be binary data. Oh, some more Python. Okay, cool. So again, in the base64 encoded blob, there was some Python, which had some more base64 encoded stuff. We decoded that, and that had some more base64 encoded stuff. I don't really understand why they encode it so many levels. Again, this just might be to hinder automated analysis. Obviously, though, this is not something that will hinder a malware analysis. I'm going to just grab the hash of this file, share that here. And here's the VirusTotal link for that as well. So you can follow along. I'll also post this binary to the malware collection on Objective-C. I should have done that before. My bad. Okay, so now we have some, looks like, unencoded Python. So we can start looking at this. Again, let's maybe try to beautify this again, make it easier to read. Let's go back to the beautifier script here. No luck. Let's try, maybe CyberChef will be better. Well, we tried. It's okay, we can do this manually. So if we open a new doc, we'll just, this is short. So we can see it's, again, doing things like importing a bunch of modules, the sub process, it has a command, it looks for little snitch, which is kind of interesting. That's not something that common. But again, it probably doesn't want to persist or perhaps execute a logic if little snitch is installed because it'll detect it. And if you do a bunch of Mac malware analysis, you start getting familiar with payloads, the ones that attackers use commonly. So, looking for little snitch is something that you don't see a lot. So if you see this in some Python code, immediately you think, oh, this is probably something I've seen before. So what we can do is we can Google this string, and I do this a lot. If I see an embedded payload, 5 out of 10 times the attackers have not written this themselves. They've copied and pasted, modified. Let's see if we can find this. I know this exists. I'm just trying to write the right query for that. Oh, no, we didn't want to do that. Oh, wow. Okay. There's a blog that I wrote that has this. So if we go to little snitch, we can see again a previous blog. We looked at some other malware that has some embedded Python that basically does the exact same thing. So ps.ef, so it's going to get the process list. grep is going to look in the process list for whatever you specify. Here's little snitch. So this is basically going to tell the malware if little snitch is running. So if we go back to the malware, we can see again, their payload matches this exactly. So whatever that payload was in this blog from 2017, they're using exactly the same thing. So if we scroll down a little bit, again, this was in a malicious Word document, we can see that what this code does is it checks for a little snitch, executes RC4 to decrypt the payload, and then execute that. And it turns out that, yes, this Python looks familiar, and I say it's taken from the MPyre project. MPyre project is a Python exploitation framework written in Python 2.7. It's very commonly used in these, let's say, less sophisticated malware attacks. Basically, what the attackers will do is they will write an infection mechanism that might be a document with macros, malicious Discord application, and then what they'll do is they are way too lazy or they don't have the skills to write their own persistent implant. So they just Google, find a common one, something like MPyre, which again is like a red team tool, again, post-exploitation agent, and then they'll just grab that and they will use that as their payload. So that's exactly what the attacker did in this case. So basically, they will, when the user double clicks on the Discord application, it'll decode all these base64 encoded chunks, and then it'll ultimately get to MPyre, which will download and execute more logic. Now we have one more chunk of base64 encoded logic here. We can see it's called screencast base64. So if we go back to Python, we can hopefully decode that as well. So let's just call it C. Let me see. Okay, so here we can see that decodes to system profiler, SP hardware data type. They then pipe that into awk. And then while true, so in a while loop forever, they basically execute screen capture and they output it to temp.allo.png. And then it looks like they curl that to an IP address. So let's grab this. And again, let's put this in a document and format this a little better so that we can follow along. Let's make this a little bigger. So while true, do, again, this might mess up the formatting, but it'll make it easier for us to read. And then that's the done loop. Okay, so it looks like this part of the malware, this payload, is going to continue to execute the built-in screen capture utility. And then that will capture the user's screen. And then they use curl, which again is a built-in utility. And they then take that payload, alloy.png, and upload it to this IP address, specifically 37.1.221.204 handler.php. So this malware we've now illustrated has the ability to capture basically your screen and upload it to the attacker's command and control server. Mike points out that reusing payloads also a good method to make attribution hard. That's a question, and that is exactly correct. If you're looking at a malicious piece of code and the payload they're using matches a known open source payload, really you can't say a lot about attribution. Whereas if the attackers are writing their own, that unto itself becomes a signature. So again, good point, Mike. That's definitely something that attackers will likely do. My guess in this scenario, it's probably more that they just don't have the level of sophistication. We can look, for example, at the signing information, and we can see that it's unsigned. So the attackers didn't even try to sign this application, which means that if the user downloads this from the web, Gatekeeper will block that application. So again, that's pretty lame from from malware point of view. Like it's not even Gatekeeper is going to kind of stop it in its tracks. Um, and how we saw this code signing information, we used what's your sign. It's a tool I wrote. It basically adds a a menu item to the right or a command or control click, whatever, right click, yeah, control click menu. So if you highlight something and click signing information, it tells you what kind of item it is. You can view the hashes of this. For an application, it will be the hash of the main binary because again, an application is really just a folder and you can't like hash a folder. So this is the main executable binary. And if it has any entitlements, and we'll talk about entitlements later, I'll show these and other interesting. So this is just a nice UI-based way to get code signing information about that. So let's now run this. I'm going to disconnect from the network just because I don't want to be sending this to the attacker, although maybe they're watching the live stream. And we will now execute this and see what it does. So since doesn't do much. Okay, so first BlockWalk pops up and tells us that Python has installed a new launch daemon or agent. So BlockWalk is a code I wrote, a program I wrote for utility. And basically what it does is it monitors common persistence locations. And if something goes to persist, it basically will alert you and say, hey, just to let you know, this Discord application you just ran installed a launch agent. Like, are you cool with that? So this is cool because if you're a power user, it gives you immediately more insight into that. So we can look at the process ancestry. We can see that, okay, yes, this was a result of discord.app executing bash, executing Python. And what Python then persisted was something called .systemKeeper. Dot makes it hidden from Finder, from the UI. So again, that's immediately suspicious. And then we can see that the startup file is com.apple.systemkeeper.plist. And again, it points to something called systemkeeper. So now we can go look at the plist and that file to see what they persisted. So sometimes if I'm rushed or don't have a ton of time, I'll just run the malware in a VM and it's going to persist, and something like BlockWalk will tell me what it persisted, and then I can just go grab the payload or what it persists. Like a lot of times I'm not as interested in the install mechanism. I mean, if I have time, I'll definitely poke around. But again, usually the more interesting thing is what the malware persists. So we're just going to click allow to allow that because I don't want it to delete it. If we now come and run KnockKnock, we'll kick this off in the background. KnockKnock is another utility I wrote, and what it does is it will enumerate, yes, thank you, friends. It will enumerate all persistent software. So hopefully it should find this malware. BlockWalk provides you kind of real-time protection. KnockKnock you can run kind of after the fact. So for example, if someone's computer I suspect is infected, what I will do is I will bring KnockKnock and run it because the majority of Mac malware is going to persist. So we come here and we can see there's a bunch of stuff that's persisted. VMware tools, do not disturb BlockWalk. BlockWalk again, because it persists as a daemon and agent. And then there's something called systemkeeper. We can click on info and we can see, okay, it's hash. We can see some code signing information. We can see that it is unsigned. And a cool feature of the latest version of KnockKnock, you can actually click on the property list and it'll open it right there. So you don't have to go and dig around to find the content of that. So we can see that the malware has persisted something called com.apple.systemkeeper.plist, and the contents of this plist are here. We can see the label is called systemkeeper. I don't know why. And we can see again the arguments to this launch agent are something called systemkeeper and then something called helper. So when you write a plist in the program arguments array is how you specify what should be executed. So in this case, when this plist is run, and since run at load is set to true, this tells macOS every time the user logs in, for example, following a reboot, please automatically execute whatever is specified in here. So this is how the malware gets persistence. This is how the malware will be continually executed even if the computer is rebooted. So we can now go into this hidden system directory and look at these two files. So we thank KnockKnock for detecting that. If we had the network adapter enabled and the setting to talk to virus total, it would send a hash of the file to virus total. And if it was a known piece of malware, it would be flagged. And that's something you can turn off if you don't want that integration. Okay, so the other tool well, no, let me just grab this really quick. So another tool I want to grab and show you is something called MonitorKit UI. So my day job is to work for Digital Security. And one of the cool things we're working on at Digital Security is an open source monitoring framework that will do things like process monitoring, file monitoring, detect USB insertions, detect when the lid on your laptop is open, when something persists, et cetera, et cetera, et cetera. So this is not yet released, but I briefly want to demo it. It's kind of beta, so don't judge it too much. So we're going to execute it as root because it taps into the operating system to do its logic. Okay, so should be up and running. Cool. So I'm interested in file and let's say process events. So this UI is going to have some more interesting stuff, but we can now see we have a nice UI-based process monitor. And again, we're going to add features like searching and all this stuff. But basically, we can see continually curl is being executed, continually bash is being executed, continually Python is being executed. So something is obviously going on in the background. And then we can see, oh, look, screen capture utility. So very easily, we can determine that what we suspected, what we decoded the malware's payload to execute, we can actually see that now it's successfully executing, and we can see that live. If we come look at file events, we can turn this on. Again, the release version will have filtering options, but if we, I think, pause this, we can go back and we can see that it's creating this temp.alloy file many times. Which again, as we saw in the payload for the malware, this was where the malware was saving the screen capture utility to. So let's go look at those files now. Again, these are what the malware has persisted on the system. So it was in the system directory. Yeah. Hidden system directory. Come on. Okay, there we go. We have to run ls with -LART because, again, the attacker or the malware named the malware with a dot in the front, which basically hides them. I mean, you can still see them, obviously, but you have to execute, for example, ls with the -LART or something like I think in Finder you can say show hidden files, but like the average user just looking around is not going to see those files. Is there some way to fix the bizarrely low frame rate on dock bouncing animations in VMware? I don't know. That's a good question. There's a lot of things I'd like to fix in VMware, but overall it does a pretty good job. We also have this thing spinning here. I don't know if that's like so when you run an Automator script, I guess there's like a UI indication that the script is still running. So obviously this malware is not that stealthy. Oh, so cool. So let's try to see if we can see these hidden files in Command-Shift-Dot. Command-Shift-Dot. Whoa, awesome. I didn't know that. TIL. Cool. So, okay, we can also see hidden files in Finder by hitting Command-Shift-Dot. So, thank you. I'm learning lots today. So here we can see the two files that the malware is persisting. So if we run the file command on these, we can, again, this is kind of what I first always do, see if it's okay, in this case, it's an ASCII text, not an executable. And the second one was .systemkeeper. And it's a Python script, which isn't too surprising because the other components of the malware were Python. So again, if we go back to KnockKnock, we can see it's persisted as a launch agent, and we can see that, again, it's going to tell the system to execute the system keeper, which is our Python script. And then it's going to pass in as the second argument .helper. So this Python script probably expects an argument. So if we look at this Python script, more base64 encoded data. It's okay. We know how to decode this well. Just layers. It's like an onion. Okay, so D equals, oh no, D equals, here we go. We already had the backtick. So base64 decode. So they're going to execute a base64 decoded encoded Python script. Okay, and this is what we saw before. This is the Python. So I'm not sure why that script is still encoded, because I don't think that means it's going to. Oh no, yeah, okay, so they decode it at runtime. So again, the operating system is going to execute this, and you can see that all the script does is call base64 decode on the payload and then exec that. So basically, it's never in the clear on the system, but we can very easily manually decode it, as we just did. Here we go in Python, and we can see again, this is the looks like part of the code from MPyre, or at least they stole the part where they look for little snitch. And then it looks like they basically are generating a request to this. And somewhere in here, it's probably executing that arg0, arg1 rather, which was passed in, which is that second file. So if we go back and look at what that second file was, it was .helper. We can see, oh, yes, okay, so this is the other thing we manually decoded. They have now decoded this and saved it to the file system. And again, are passing this in as an argument to the Python script. So again, as we saw, we said, okay, they're likely capturing screen captures, setting it to tmp.alloy.png, and then exfiltrating that to this IP address. Via MonitorKit, we can see that happening. We could see this file being created, and because of the process monitor, we could see continually that. Let's just pause this as well. We could see that the screen capture utility was also being executed. So this just confirms what we thought the malware was doing. So let's see if that file is created. So let's see, open temp allo.png. And it might be in the middle of creating it, so looks like it's blank. Let's try it again. Maybe let's copy that to the desktop. Oh, don't even know how to copy. Survey says, oh, awesome. Okay, so this is the malware capturing us. So, kind of meta, but it's a screen capture of what we're working on. So now we can basically summarize what the malware is doing. Again, it comes in as this discord.application, and we showed that it's unsigned via what's your sign. But if the user is tricked into executing this and running it, they will have a persistently installed launch agent that will execute a Python script that will, looks like, connect to a command and control server. Oh, VM, don't die, come on. And also then continually take screen captures of their desktop and send it, as we showed, to this IP address right here. Is it this one? Yeah, the helper. So that's kind of a wrap. At this point, we could probably write some indicators of compromises, some IOCs. Likely the property list name is a good indicator. Other such things. Looks like my VM has kind of decided to, come on, take a nap. I'm going to blame it on the poorly written malware. Anyways, close. Okay, so that's kind of a wrap for this piece. Again, kind of this malware just came out. It wasn't detected, but nothing really that sophisticated. If you want more information about this malware, I think Malwarebytes wrote a little bit more about this. Didn't really go into as many technical details, but again, all credit to them for discovering that. And again, here they show that they extracted the same payload and talk about what it does. Automator script that decodes and executes a Python payload, then repeatedly takes screenshots and uploads them to a command and control server. Awesome. So that wraps up our malware part of the stream. We're now